What is up, mathletes? Welcome back to another episode of Math with Dr. Math. And today's big topic is absolute value inequalities. Have you heard about them? All right, folks, so let's go ahead and dive in this. And we're going to dive in this looking at the two big hitters, the problems you're going to see the most of. All right, so I want to make this clear. All right, we're going to look at some. Right now, we're going to focus on positive numbers on one side of the inequality, but at the end of the video, we're going to take a look at negative numbers because people also make a lot of errors when we look at negative numbers. So stick around to the end. All right, so let's begin by thanking our sponsors. Today's video was brought to you by the letter E. All right. So the absolute value of x is greater than 3. So we're looking at absolute value, which represents a distance. So which numbers have a distance greater than 3? Well, we know that all the numbers that are greater than 3 have a distance from 0 greater than 3. Or we also know that all the numbers that are less than -3. Right? So for example, -4. Well, what's the distance from -4 to 0? Well, that distance is 4 units, which is also greater than 3. All right, so if you don't like using that definition, what you could do is, one way we like to think about it is, for the first case, just take away the absolute value signs and you're done, right? So you're left with x is greater than 3. Boom, and that gives you this side. And for the other one, what we do is we change the inequality, we change the direction. Notice how the direction changed. And then instead of having a +3, because you changed the direction, we also change the sign. So make sure you make a note of that. All right, so these are the two things we get when we have the absolute value is greater than a number. So what happens when we have the absolute value less than a positive number? All right, so when we have this case, what we're gonna do is we're gonna see that x is trapped between -3 and 3. So we have our quantity here, whatever's inside the absolute value is gonna be trapped between the positive of this number and the negative of this number here. All right, so as we jump into these problems, as we do these examples, what I want you to make sure is that you always do first is make sure the inequalities are isolated all by themselves. Then you could get to work. All right, so let's take a look and let's put these principles into use. All right, so here's our first example. You have an inequality, but notice we said the first thing we want to do is isolate this inequality. We need to get it by itself. All right, so here we go. So first we go ahead and we want to move that -4 to the other side, right? So we're going to go ahead and add 4 to both sides. All right, because our goal is to get this absolute value isolated by itself. So we go ahead and add 4 to both sides. So we add 4 here, add 4 there, add here 4, there 4, everywhere 4, 4. All right, so these end up canceling out. Bam, so far good. So we have -16 plus 4, that gives us -12. Is our absolute value by itself? That's what you're always asking yourself. Well, not yet, right? It's not by itself yet. So what we're gonna do is now we divide by that -3, right? You're solving. So we're gonna divide by the -3, but the reason I chose this example is because remember, when you divide both sides by -3, this inequality changes directions. So make sure in your notes that's crystal clear. When you divide or multiply by negative, the sign of this inequality, boom, changes directions. Boom, so jot that down, big note. So now you have the absolute value greater than or equal to 4. So when we said the absolute value is greater than, that's when you have the two cases. The first case, all we do is remove the absolute value, and that's what we get over here. Or the second possibility is, again, we remove the absolute value, but we change the sign of the inequality. So don't forget to change that sign of the inequality. But when you do that, right, we also change the sign of our number. So instead of having positive 4, it's negative 4. Why is that? Again, we're trying to find all the numbers that have a distance from 0 that is greater than 4. So any number that you pick over here, right, is going to have a distance from 0 that's greater than 4 units. And any number that you pick over here, when you look at the distance from 0, is also going to be greater than 4. So this is how we get our graph. So notice what we graphed. We graphed all the numbers that are greater than or equal to 4. So notice we have a closed bracket there, meaning that it can be equal to 4, and we shade everything to the right. If you're using some textbooks, instead of using closed brackets, they might use a closed circle. But again, as we discussed in our other video, it's just notation. It means the same exact thing. And then on our other side, we have x is less than or equal to negative 4. So we shade all the numbers that are less than or equal to negative 4. So once again, we have our closed bracket because it can equal negative 4, and we shade everything to the left. And again, depending on which textbook you're using, they might choose to use a closed circle and the arrow pointing to the left. But they mean the same exact thing. All right. And then we have, so this is our graphical representation here. And now, if you want to put this in interval notation, notice our graph is starting off from left to right. It goes from negative infinity, right? So we have negative infinity over there. And it keeps going until it hits negative 4. So we have negative infinity. We always have an open parentheses for negative infinity, all the way until 4. And then we have a big gap in between here. So whenever you have a big gap, you put a U, right? That represents union. And then we start back up at 4, and it's a closed bracket because it's included, and we go all the way to positive infinity. All right, so again, as you're taking the notes, a big takeaway from here is make sure your absolute value is always isolated, right? Even on Sunday. All right, let's do another example. All right, so we're gonna go ahead and isolate this absolute value. So let's subtract 9 from both sides. All right, so those 9s will cancel. So these 9s will cancel. And now we're left with negative 2 times the absolute value of 4x plus 1 being greater than negative 6. And our inequality is still not by itself. We have that negative 2 that's sitting out in front. So we're gonna go ahead and we're gonna divide both sides by negative 2, right, to get rid of that negative 2. All right, once again, you divided by a negative. So don't forget, when you divide by that negative, you gotta change that sign of the inequality. All right, so negative 6 divided by negative 2 gives us that positive 3. And now our absolute value is isolated. So once it's isolated, look what we have. We have the absolute value is less than a positive number. So what we said earlier, right, in the beginning of the video, is that this quantity in here is going to be trapped between 3 and its opposite, negative 3. All right, so we put whatever's inside here, right, this quantity, that's in the middle. So it's trapped between the negative 3 and the 3. All right, and now we go ahead and we solve this inequality. So we're gonna go ahead and subtract, because we're trying to solve for x. So we subtract 1 from both sides, from all 3 sides, I should say, right? So doing that, these ones cancel. And then so we're left with 4x, right? 4x is now trapped between 2, and do the math over here, and you get negative 4. Again, we're trying to solve for x. So we have 4 times x, so we're going to divide all 3 sides here by 4. And in doing so, we get x now is trapped between negative 1 and 1/2. All right, so if we were to graph that, we're going to see that we do not have or equals to, right? There's no lines underneath here. So what that tells us in terms of our graph is that we have an open parentheses. It's not a closed bracket, right? Because we do not have or equals to here. So we start at -1 and we finish at 1/2. So x could be any number between -1 and 1/2. So every single number in here is a possible solution. All right, and again, writing this in interval notation, we start at -1, open parentheses, and we end all the way at +1/2. All right, so key notes here. Number 1, always isolate the absolute value, just as we talked about. And number 2, don't forget, it's easy to do. When you divide by a negative or multiply by a negative number, that sign has to change. So a few things that I always see students forget. So please make sure that you jot that down. All right, let's continue the march here. All right, so once again, we have this inequality and we're trying to solve for the absolute value. All right, so here we go. We need to get the absolute value by itself. So we're gonna go ahead and subtract 12 from both sides, right? Because we wanna cancel those 12s. So 4 times the absolute value of 6x minus 1 is less than or equal to -8. All right, we want to get this absolute value by itself, so we're going to go ahead and divide both sides by this 4 that's sitting out in the front. So let's go ahead and let's cancel out that 4. So now you're left with the absolute value being less than a negative. Well, let's think about this. The absolute value represents a distance. And a distance, the smallest distance that you could have is 0. So there's no way, and I mean no way, that this absolute value can be less than -2, right? Because the smallest number this could represent is 0. So even 0 is not less than a negative. So right here, there's no need to proceed. You're finished. You already know that there is no solution. So you could write no solution, or you could have our no solution symbol, right? Excellent. So jot that down. Whenever you have the absolute value less than a number, less than a negative number, you're done. Even if this were at 0, right? That wouldn't make sense. A distance being less than, if that were at 0, it just doesn't make sense. So that's how you know you get a no solution. So that's a big note to jot down. Jot it down, or else you will pay. All right, let's do another one. So once again, we have the absolute value that we need to isolate. So we're gonna go ahead and subtract 5 from both sides. All right, so let's cancel those 5s. And so now we're left with -6 times the absolute value is less than or equal to 12. Divide both sides by -6, so we could cancel these -6's. All right. And so we're left with the absolute value here. This absolute value of x plus 7 is now, notice you're dividing by a negative. So when you divide by a negative, don't forget to change that sign, right? I have it sprinkled throughout this video to hit that on the head, right? I'm trying to send a message. So when you divide by a negative, we change the sign. And don't forget 12 divided by -6 is -2. But now, we're saying, where is the absolute value greater than or equal to this negative? Well, this distance, we said the smallest distance that you could have is 0. And 0 is always greater than -2. So whenever you have the absolute value greater than, and even if it's equal to, it doesn't matter, right? Greater than a negative, that's gonna be true 100% of the time. So that means no matter what number you plug in here, this is always going to end up being bigger than -2. So we say all real numbers is our solution. You give me a number, I plug it in, it's going to give me a true statement. All right, so now make sure that you go ahead and you jot down those notes and all those cases, right? Because there's a lot of different cases that you have to think about, and I want you to organize what we just did. And again, if you have any questions, comment down below. I'll be glad to clarify anything because there's a lot in that video right there. All right, folks, hopefully this was helpful. Don't forget to smash that like button, subscribe, and we'll see you in the next video. Peace.